We're going to answer this question briefly. So this question says here, if the above system is at equilibrium, the values of T1 and T2 are. So this is a system that is in equilibrium. So one force here is attached towards this um, point, and then this one towards this side, and this force makes an angle of 45 degrees with respect to the vertical. Same here with 60 degrees with respect to the vertical. So we have to calculate T1, T2, and this T1 means tension. Tension is when when force act in opposite direction. So now if someone is dragging this thing this way to the right, another person is dragging this rope to the left, there is a tension there, T. So now you see this 100 Newton is drawing whatever that is in this point downward, that's vertical, and then this one is drawing it upward and towards the right at the same time. So the theory to solve this is we use triangle of forces to solve that. So we are going to redraw these three forces into represent these three forces with the three sides of a triangle. It can be any type of triangle depending on the value of our angles. So let's start now. Start doing the representation. I'll start with this 100 Newton that is vertically downward because that's the one that is most certain. Downward, labeled 100 Newton. Being able to draw out the triangle is where the challenge is. Now, you see this other T1. T1 acts towards that direction, and the angle it makes with the horizontal is 45 degrees. So, how do you extract this T1 tension and fix it here on the triangle? Now, when you come to T1 and extend its bottom, extend its line of action. When you extend its line of action, you see this angle 45 is now corresponding with this angle here, 45. So what that means is that T, angle T, angle T, angle, what this means that the tension T acts at angle 45 degrees to the horizontal. So this T here, we bring it down here. So that's our T. That is our T. Another way to look at it is this. Okay, let's just continue. So now T2, how do we T2 act in this direction? Now how do we fix it on the triangle? Now if you extend that as well, if you extend its line of action, you see here is angle 60. So that means the angle T2 makes with this horizontal, that's if you carry the way it is and place here, this is it. The angle it makes there is 60 degrees, and this one is 45 degrees. So this is T2 here, and this is T1. So I've successfully represented the three forces into a triangle, a scaling triangle. So now what remains now is how to solve this, how to resolve this triangle or solve it to find T1 and T2. So if you still have confusion on how to transfer the three forces into triangle, remember you can extend line of action of any of the force, like this 100 Newton, you can extend its line of action. If you extend it down there, you will see that this 45 degrees here is alternate to this. So you see, from here, that's a point. If I call this place point A, B, C, that's where you see point A, B, C. So you see, this alternate place will be 45. That's how to transfer it. Same goes here. You see that 60 here will alternate this one. That is how you get this one, or you see it from this other angle. So that's how to do the transferring. So let's solve this triangle. Now, triangle that is not a right angle triangle, we can use cosine rule or sine rule to solve it. But here we are going to use sine rule. We are using sine rule because we have two angles and one side. So sine rule states that you will do the side divided by the angle opposite it over another side divided by sine of the angle opposite another side divided by the sine angle opposite it. So let's find the angle here. The angle here, we call it theta. That angle there will be 180 minus, you open bracket, 60 plus 45. 60 plus 45. That will be 180. Sum of angle in sum of interior angle of a triangle is 180. So to get this one will be this plus that is 105. So if you minus that, you have 75. So that means that angle there, theta, is 75 degrees. So I write it down, 75 degrees. 75 degrees. So sine rule states that 100 here divided by the sine of the angle opposite it, that's 100 over sine 75, will be the same as T1 here, that's the side of this triangle, divided by the sine of the angle opposite it, that's divided by sine 60, equals to T2 there, divided by sine of angle opposite, that's sine 45. So basically what I've represented here is called sine rule, used to find the side and angle of a triangle. So it means the ratio of the side to the angle opposite the triangle will be the same for all the three sides. That's the sine rule. That's what it states. So now for us to solve for T1, we are going to pick any of the two any of the two paths that we prefer. That will give us, see this one. I'll pick this path and solve. So when I solve this path, it's going to give me T1. When I'm done, I'll then come and pick this other one here, and not this one. I'll combine this one and this one to get T2. So that's how we do this. So let me solve for T1. If I make T1 the subject of the formula there, T1 will be equals to 100 sine 60. 100 sine 60 divided by sine 75. That's if you are solving this first ratio, with this first fraction and this second fraction. If you multiply both sides and make T1 the subject, this is what you have. And then we know that sine 60, is a special angle. Sine 60 is root 3 over 2. So we have 100 times square root of 3 over 2, then divided by sine 75. Sine 75, which equals to 2 divided 150. You now have 50 root 3. divided by sine 75. So this equals to, we can still write it this way: 50 root 3 times 1 over sine 75. 75. So the reciprocal of sine is called cosec or cosecant. 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 Abbreviated, can be shortened by saying cosec, then abbreviated CSC. So if we substitute that there, what we'll be having is 50 root 3 cosecant of 75 degrees. So our T1 is 50 root 3 cosecant of 75 degrees. So we check in our option. Option A has that as our T1. Option B doesn't have that. Option C doesn't have that. So if it were me, I would have like, okay, A, we'll both on A for now. But I can't really say because I have to calculate for T2. Who knows? T2 may not be here. So to calculate for T2, I'll combine the first fraction here and the third fraction here. So that will be 100 over sine 75 equals to T2 over sine 45. If you make T2 the subject of that equation, you have that T2 will now be 100 sine 45 divided by sine 75. So sine 45 is 1 over root 2. It's a special angle. So this is 100 times 1 divided by root 2. Then everything divided by sine 75. Let me create space down so we can keep solving. So this is equals to, if you rationalize 1 over root 2, actually in mathematics there's something we call rationalization of sort. So this is 1 over root 2. Rationalizing it means you multiply it by root 2 over root 2. Root 2 times root 2 will give you 2. So you end up having root 2 divided by 2. That we rationalize this. Rationalization means a way of simplifying such that you remove the root function or the square root on the denominator. So if you rationalize the sort here, you end up having 100 times square root of 2 over 2, then divided by sine 75. So this will be equals to, if these two cancel this 150, you now have 50 square root of 2 divided by sine 75, which is the same thing as 50 square root of 2 times 1 over sine 75. So if you process that, you now have 50 square root of 2 cosecant of what? 75 degrees. So if you check which of the T2 in the option matches that, option A. So you see our T1 is 50 root 3 cosecant 75, which is A here, and our T2 is 50 root 2 cosecant 75, which is still A here. So the correct answer to that question is option A. Correct answer is option A. So subscribe to my channel to boost it and move the ministry forward. And then for real-time classes, you can join my WhatsApp group through the link in the description. So this is how this thing is done. Thank you.